Okay, hi everyone, welcome back to this video series on Cisco ASA Firewall. Advanced ACL features. Cisco ASA provides many advanced packet filtering features to suit any network environments. These features include object grouping, standard ACLs, time-based ACLs, downloadable ACLs. Object grouping. Object grouping is a way to group similar items together to reduce the number of ACEs. Without object grouping, the configuration of the security appliance may contain thousands of lines of ACEs, which can become hard to manage. The security appliance follows the multiplication factor rule when ACEs are defined. For example, if 3 outside hosts need to access 2 internal servers running HTTP and SMTP services, the security appliance will have 12 host-based ACEs calculated as follows. Number of ACEs equals 2 internal servers multiplied by 3 outside hosts multiply 2 services equals 12. If you use object grouping, you can reduce the number of ACEs to just a single entry. Object grouping can cluster objects such as internal servers into one group and outside hosts into another. The security appliance can also combine both TCP services into a service object group. All these groups can be linked to each other in one ACE. Object types. The security appliance supports 4 different types of objects that can group similar items or services. They include protocol, network, service, ICMP-Type protocol. A protocol-based object group combines IP protocols such as TCP, UDP, and ICMP into one object. For example, if you want to group both TCP and UDP services of DNS, you can create an object group and add TCP and UDP protocols into that group. Network. A network-based object group specifies a list of IP host, subnet or network addresses. Defining a network number-based object group is very similar to defining a protocol-based object group. Service. A service-based object group is used to cluster the TCP and or UDP services together. By using the service-based object group, you can group TCP, UDP, or TCP and UDP ports into an object. ICMP-Type. The ICMP protocol uses unique types to send control messages as documented in RFC 792. Using the ICMP-Type object group, you can group the necessary types required to meet an organization's security needs. For example, you can create an object group called Echo you can create an object group called Echo to group Echo and Echo reply. These 2 ICMP types are used when a user issues the ping command. Configuration of object types. If you prefer to use CLI, you can configure object groups by using the object group command followed by the object type. The complete syntax is object group protocol network ICMP type GRP ID service GRP ID TCP UDP. For example, if you want to set up a protocol based group object, use the object group protocol command followed by the name of the object group as shown in example 4.5. The protocol object command is used to set up an object group called TCP-UDP to group the TCP and UDP protocols. The security appliance enables you to add a description under an object group. In this example, the description grouping of TCP and UDP protocols identifies this group. So you can see here an example 4.5, configuration of protocol-based group object group. As mentioned earlier, an object group can be nested into another object group. You do so by using the group object command. In example 4.6, another protocol-based object group called IP protocols is set up to include GRE as the IP protocol. This object group also contains the TCP-UDP object group defined in the preceding example. The description nested object group to include GRE, TCP, and UDP is added to this group. Defining an object group via ASDM is even simpler. Navigate to Configuration, Firewall, Objects, Service Groups, Add, and select a protocol group from the drop-down menu. ASDM opens a new window where you can specify a group name and an optional description. You can also select the desired protocol from an existing predefined protocol list. You can even add a new IP protocol if it is not in the predefined protocol list. As illustrated in figure 4.6, a new protocol-based object group called TCP-UDP is added with a description of group TCP and UDP protocols. From the existing service groups list, both TCP and UDP protocols are added to the members in a group list. Click OK when you are finished. So you can see here figure 4.6, a protocol-based object group through ASDM. If you want to set up services-based object group, use the object group service command followed by the name of the object group as shown in example 4.7. The service object command is used to set up an object group called all services to group the HTTP, DNS, ICMP, Echo, and GRE protocols. The security appliance enables you to add a description under an object group. In this example, the description grouping of all services identifies the group. So you can see here example 4.7, configuration of server-based objects group. Want to define a service group object via ASDM, navigate to Configuration, Firewall, Objects, Service Groups, Add and select Service Group from the drop-down menu. ASDM opens a new window where you can specify a service group name and an optional description. You can also select the desired protocols, TCP, UDP, and/or ICMP services from an existing predefined protocol list. You can even add a new protocol or service if it is not in the predefined list. In figure 4.7, a new service-based object group called All Services is added with a description of grouping of all services. From the existing service groups list, select HTTP and move it to the members in group list. Similarly, select domain, GRE, and ICMP Echo to the members in group list. Click OK when you are finished. Object grouping and ACLs. After object groups have been set up, you can use them in an ACL. The command syntax to define an ACE using object group is, as you can see here, table 46 defines the arguments used in an object group ACE that are different from the ones in table 4.2. In figure 4.8, the inside network has two servers, both running HTTP and SMTP services. If two hosts on the outside network try to access those servers, then 8 ACEs should be configured to allow the hosts to communicate with each other. By using group object parameters in the ACE, you can reduce the viewable number of ACEs to 1. Example 4.8 shows the corresponding ACE using the object groups. A protocol-based object group called TCP is set up with the TCP protocol. The two network object groups configured are internal servers and internet hosts. The internal servers object group specifies the IP address of the servers that are on the inside network, whereas internet host is configured with the IP addresses of the hosts that are allowed to access the internal servers. Or a service-based object group called HTTP SMTP is set up to group. So you can see here inbound packet filtering using groups, and table 4.6 ACE defining using object group. After configuring the ACL, you can bind it to an interface for traffic filtering, as shown in example 4.9. The ACL outside access is applied to the outside interface in the inbound direction. To define an ACL with object groups through ASDM, simply navigate to Configuration, Firewall, Access Rules, select the pull-down Add list and click Add Access Rule. ASDM opens a new window where you can select the pre-configured object groups in the source and destination services and address as shown in figure 4.9. An ACL is being configured for the outside interface that allows traffic from the internet host object group to the internal servers object group on the HTTP SMTP service object group. Standard ACLs. As mentioned earlier in this chapter, standard ACLs are used when the source network in the traffic is not important. These ACLs are used by processes such as OSPF and VPN tunnels to identify traffic based on the destination IP addresses. You define standard ACLs by using the access list command and the standard keyboard after the ACL name. The command syntax to define a standard ACE is access list ID standard, line num, deny, permit, any host IP address, subnet mask. In example 4.10, the security appliance identifies traffic destined for host 192.168.10.100 and network 192.168.20.0 and denies all other traffic explicitly. The ACL name is DE NE. So you can see here an example 4.10, configuration of a standard ACL. After a standard ACL is defined, it must be applied to a process for implementation. In example 4.11, A route map called OSPF map is set up to use the standard ACL configured in the previous example. If you prefer to use ASDM to define a standard ACL, browse to Configuration, Firewall, Advanced Standard ACL, Add ACL. ASDM opens a new window where you can specify an ACL name. Click OK to add this ACL in the system. After the ACL is defined, you must add access control entries ACE. Click Add ACE and specify the destination network that you want to permit or deny. In figure 410, an ACL called DES net is added with two ACEs. The first ACE permits traffic destined to 192.168.10.100, whereas the second ACE allows traffic destined to 192.168.20.0/24 network. Time-based ACLs. The security appliance can apply the ACLs based on the time interval to allow or deny network access. These rules, commonly referred to as time-based ACLs, can prevent users from accessing the network services when the packets arrive outside the pre-configured time intervals. The ASA relies on the system's clock when the time-based ACLs are evaluated. Consequently, it is important to ensure that the system clock is accurate, and thus the use of Network Time Protocol (NTP) is highly recommended. You can use the time-based ACLs with the extended IPv6 and web type ACLs. So you can see here standard ACL definition. ACL, which we all know is access control list. The security appliances enable you to specify two different types of time restrictions. Absolute. Using the absolute function, you can specify the values based on a start and or an end time. This function is useful in cases where a company hires consultants for a period of time and wants to restrict access when they leave. In this case, you can set an absolute time and specify the start and the end time. After the time period expires, the consultants cannot pass through the security appliance. The start and end times are optional. If no start time is provided, the security appliance assumes that the ACL needs to be applied right away. If no end time is configured, the security appliance applies the ACL indefinitely. Additionally, only one instance of the absolute parameter is allowed to be set up in a given time range. Periodic. Using the periodic function, you can specify the values based on the recurring events. The security appliance provides many easy to configure parameters to suit an environment. Time-based ACLs using this option are useful when an enterprise wants to allow user access during the normal business hours on the weekend and wishes to deny access over the weekends. Cisco ASA enables you to configure multiple instances of the periodic parameter. If both absolute and periodic parameters are configured in a time range, the absolute time parameters are evaluated first. Before the periodic time value in periodic time ranges, you can configure a day of the week, such as Monday, specify the keyword weekdays for a work week from Monday to Friday, or specify the keyword weekend for Saturday and Sunday. The security appliance can further the restrictions on the user by setting the optional 24-hour format HHMM time specifications. You can set up the time-based ACLs by using the time range command followed by the name of this entity. In example 412, the administrator has created a time range policy called consultant hours for a new consultant whose start date is 8 a.m. on June 1st, 2009, and an end time date is 5 o'clock p.m. on December 31st, 2009. The administrator has created another time range policy called business hours for the regular employees who work from 8 a.m. to 5 p.m. on weekdays and from 8 a.m. to 12 p.m. on Saturdays. So you can see here example 412, time range configuration. Using ASDM, configure time range policies under configuration, firewall, objects, time ranges. Add ASDM opens a new window where you can specify a time range, policy name, and define the absolute and or periodic attributes as shown in figure 411. The administrator has defined a policy in ASDM similar to the policy in example 412. After a time range entry has been set up, the next step is to link it to the ACL by using the time range keyword as illustrated in example 413, in which the administrator allows outside users access to an internal web server 209.165.202.131 during business hours 8 a.m. to 5 p.m. Monday through Friday and 8 a.m. to 12 p.m. Saturday. If the outside users try to access the servers outside this time window, the security appliance drops the packets and generates a syslog message logging this event. The ACL name is inside server and the time range name is business hours. The ACL is applied to the outside interface in the inbound direction. Using ASDM, you can link the time range policy to an ACL by editing or adding a new access rule. In figure 412, as previously defined time range policy, business hours is linked to an access rule that allows any source to send HTTP traffic to an inside server located at 209.165.202.131. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.